All right, we're going to work problem number 7 here. It says a physics student throws a softball straight up into the air. Her friend has a stopwatch and determines that the ball was in the air for a total of 3.56 seconds. They ask us to find two things. With what speed was it thrown? And how high did it rise? Okay, they give us very little information here for number 7. But let's get a picture and see what's going on. Now that ball goes straight up and straight down, but we're going to draw this as kind of an arc so that we can separate the left side where the ball goes up and the right side where the ball comes down. So I've got that the time is 3.56 seconds. And I always know that acceleration is negative 9.8, and I believe we're using 9.80 meters per second squared for these problems. Now, we're going to be careful to use the sign. Traditionally, acceleration due to gravity is negative, so we're going to stay with that. That means any velocities downward are negative, any velocities upwards are going to be positive. And that won't matter much for the first way we're going to solve this, but for the second one, it's really important. So I think the simplest way to solve one of these problems is to think of it as two parts. There's the time and the initial velocity up, and then there's the down part. And a couple of things to think about just from a concepts perspective here is that gravity slows this ball down on the way up and it speeds it up on the way down, and it does so equally. That means whatever this velocity was here, as it gets brought down to 0, it turns around, gravity speeds it back up to the same speed it left when it comes down. So I know that my initial velocity here is equal to my final velocity there with a different sign. This is positive and this is going to be negative. Or I can split this problem up into two parts and say, right now I don't know what this initial velocity is, but I do know that the final velocity on the way up is 0 meters per second. So on the upside, the final velocity is 0 meters per second. But I think a more convenient way to do this problem is to think of it on the way down, because it starts with an initial velocity of 0 meters per second. And in a lot of our formulas, it's really convenient when the initial velocity is 0, because that term just goes away. The other thing to remember here is that if it slows down equally going up and speeds up equally going down, then that time should be split evenly as well. So if it's 3.56 seconds for the whole time, the time up is going to be 1.78 seconds, and the time down is 1.78 seconds. And when we're doing the problem, we can get just this distance when we're working through it. So let's just go ahead, and if we know that the final velocity coming down with a negative sign is going to be equal to the initial velocity going up here, let's just find the final velocity over here. So for part A, we can just say that the final velocity is equal to the initial velocity plus the acceleration times the time. Since our initial velocity at the top is 0, we really have just that the final velocity is equal to the acceleration times the time. Acceleration is gravity, negative 9.81 or 80 meters per second squared, times, remember, just the time down, 1.78 seconds. So we've got 9.80 negative times 1.78 gives me negative 17.4. The second goes away. One of these seconds stays. So we have meters per second. Because we're doing the down calculation, this is a negative velocity, but we need to remember that we're just using this number to figure out what that one is on the way up. So our answer is a positive 17.4 meters per second. Now, I did not do significant digits with that problem, but that's one way that you can solve it. And then the next part is, how high did it rise? Well, now we have an initial velocity. So in part B, we can say, well, I want to know the distance. I know the initial velocity is 0 meters per second. I know the final velocity is 17.4 meters per second. I know the time is 1.78 seconds. And I would say when you're doing problems, anytime you can use numbers that have been given to you, those are probably more accurate than your calculated numbers because these do have some rounding in them. So let's just see if we have a formula that we can use that doesn't necessarily involve our calculated final velocity. So I know that the distance is equal to the initial velocity times the time plus 1/2 times a times t squared. That's going to work out pretty good. We don't even need that final velocity. And because our initial velocity is 0, 0 times that is going to take that term away. So we're really just going to have equal to 1/2 times a times t squared. That's going to be 1/2 times negative 9.80 meters per second squared times 1.78 seconds quantity squared. So 0.5 times 9.80 times 1.78 equals, I'm sorry, not square that, 1.78 squared times 9.8 times 0.5. There we go. And we get 15.5, and it's going to be negative the second squared, the second squared, negative 15.5 meters. Just indicating that that was a downward direction that it fell. And then finally, that would be the way that I would probably solve that problem. I will show you one more way to do that in the next video.